Okay, on this example, what we have is a chart and some loads on it. And the total mass for this particular chart, together with the loads, is 100 kg. And for these particular examples, we are going to determine the acceleration of the chart as well as the normal reactions on the pair of the wheels at A and B. Okay, and to simplify the problems, we neglect the mass of the wheels. Okay, so we ignore the mass of the wheel at point A and at the back here at the B. Okay, if you look into this particular figure on this chart, there is a hand on your top left corner here. There is a hand pushing the chart going in this direction. Okay, chart is moving in this direction. Okay, and as you can see also that the forces here, we can name it as F, okay, is making an angle, and that particular angle can be represented by this trigonometric here, triangle, okay? And to resolve these problems, first we want to determine the acceleration of the chart, and we can look into uh, the component, the X and the Y component, okay? Where in the X direction of the forces, okay, X direction of the forces, we will see that the chart is going in this direction. Of course, the AG here is not equal to 0. Okay, and since we know that from this pushing forces that it is going that direction, therefore the X component is here, and there will be another Fy going down. So if we resolve this into the X and Y component, yeah, you can see something like this. And in the X direction, only Fx that we have here, and Fx is equal to 4/5 in the X direction. Then that is equal to 100. 100 is M. Okay. And here, don't be confused that which one is which. This one here is the F. Okay, 100 here is F, and this one is the 100 kgm. And A is the acceleration in the X direction. And now, if we resolve this question, we can get this acceleration of the chart in the X direction. Okay, moving on. Let's look into the Y direction. Pointing up, going upwards is a positive, okay, as we can see here. Okay, and similarly, like the previous one, we will look into the forces, but in this case is the vertical or in the Y direction, where you can see that down here you have wheels that you are going to have reaction forces, okay, on both wheels. Here is NA and here is NB. And the center of mass is given here, okay, and here we have the W, which is equal to the mass of the wheels times the gravity. So now we have 1, 2, 3, and 4. 2 is pointing upwards, another 2 is pointing downwards. So uh, the NA and NB, direction force at A and B at both wheels here is positive. And then we minus the F. This is Fy, okay? And then here is the mg, the weight actually. This is the weight. And then equal to 0 because the acceleration in the y direction is 0. The chart is not going upwards or downwards. So it is equal to 0. So now you have one equation. Okay, next. We can assume that going counterclockwise, CCW is a positive. And we can calculate the moment at point G here. Okay, and as we know that moment is equal to force times the distance, perpendicular distance, or also known as the moment arm. Okay. Okay, now we look one by one. First, we look into the NA, direction force at point A here. And here is our center of rotation because we want to determine the moment at point G. So this is our center, and NA is pointing upwards, and as it goes up, here is fixed. So you can see it will make a rotation like that. And this one is positive because it is a counterclockwise. And then since the forces or the normal force here must multiply by the perpendicular distance or the moment arm, and this is our force. Then as we can see, this is our moment arm, which is 0.6. So NA times 0.6. Okay, and this one is the F. What we have here is Fy. Sorry, it is Fy. This is our Fy, and it is the particular distance from Fy to the center of rotation. Okay, Fy is here, and if we can draw the line from the center of rotation, and we can see that it should be from here to these particular lines, and you can see down here it is 0.3 plus 0.4, so that is equal to 0.7. Okay, and how about the NB from here? Since it is going that direction, okay, NB here is the center, so it will make negative because it is a clockwise motion. Okay, so NB is negative, and the distance is 0.4. Okay, this one 0.4 from the center of rotation or point G. Then we look into the x component of this fx. Okay, fx is going that way, okay, pushing that way, and it is the the point G, and the perpendicular distance is up to here. And we know that from here, it is 1.2, and down here is given 0.5. So here is 0.5. So 1.2 minus 0.5, here is 0.7. Okay, so it is fx. Okay, here is fy, fx. So now we have one equation up here, another equation up here, and we have two unknowns, and therefore we can solve these problems to get the reaction force at point A and the reaction force at point B. Okay, that's all. Thank you.